Here we're asked to consider the area under the curve for the square root of x squared plus 2 between 3 and 5. So write out the sums you would need to determine the right endpoint and left endpoint rectangle approximations for the area under the curve using 4 rectangles. Do not evaluate. Okay, so first thing I'm going to find the width. So since it's from 3 to 5, that's 2 units, and I'm dividing it into 4 pieces. That's really just, 1/2 is going to be my width. So for each of these, I'm going to multiply it by 0.5 because that's going to be, the width of my rectangles. Now my heights are my original equation, square root of x squared plus 2. But instead of x here, I really need to kind of plug in a k value. So what that means here is that I need to come up with an equation for the k value. And the only two things that we need to come up with that equation are the width, which is 0.5, and the starting value, which is 3. So if you were to think about the table, k, x of k, the starting value is at 3. X of 0 would be 3. And it's going up by 0.5 each time. So my equation for x of k is 0.5k plus 3, because that's where we are starting. So now I'm going to plug that into x here, and I'm going to get 0.5 times the square root of 0.5k plus 3 squared plus 2. So in that one there, this is going to be the equation that I have for sigma notation. I think I just got ahead of it because it was asking for each of the sums that we would need. So to write that out in expanded form, it's a little bit less fun. But basically what we would do is, for the first one, 0.5 times the square root of 3 squared plus 2. That's my first term. Plus 0.5 times square root of 3.5 squared plus 2. And then I'm going to write all these out and fast forward it because I don't want to waste your time. Okay, because again, I'm being a little bit lazy here. The first, like the left endpoint rectangles would be 1, 2, 3, these. So that would be all of the sums that I would need to find the area under the curve for left endpoint, because I'm starting at, x of 0 and going to x of 3. Now for right endpoint, same idea, except I don't use the left one. I start with this one here, and I go all the way to the end. This is for my right endpoint because I'm starting at x of 1 and going to x of 4. Again, each time, since I'm dealing with 4 rectangles, I should be adding 4 things together. So for sigma notation, again, I kind of went ahead on this one. It should be pretty straightforward from this one. You should be able to express different sums by changing the indices of each summation. So what that means is that I'll do the left endpoint in blue here. I'm starting at 0 and going to 3. And then I have this equation, 0.5 times the square root of 0.5k plus 3 squared plus 2. So that would be my left endpoint. My right endpoint I'll do in green here. K equals 1. I'm going from 1 to 4 this time. So I got 0.5 times the square root of 0.5k plus 3 squared plus 2. So what you should notice is that the argument here is the same for both, right? So what I underline here in purple is the same for left endpoint and right endpoint. The only thing that changes here is the k value that we start with and end with. So C, explain how the indices relate. Okay, that's what I just did. So you're all finished. So again, writing out the sums is just kind of a lot, which is why we use summation notation. Because even for this one, this is just 4 rectangles, and it took me a bunch of time to do. If I had like 12 rectangles, it's much easier to write this equation here one time and then use our calculator to plug in the values and get our final answers.